Digital transformation initiatives are accelerating in organizations. We're also witnessing the latest round of technological revelations, such as generative AI, Web3, and the metaverse. They all contribute to the estimated millions of trillions of bytes of data generated worldwide each day. On the receiving end of much of this data are businesses of all sizes. Managing that data is imperative for companies to survive and thrive. Data management is the process of ingesting, storing, organizing, and maintaining the data created and collected by organizations. Effective data management is a crucial piece of deploying the IT systems that run business applications and provide analytical information to help drive operational decision-making and strategic planning. The data management process includes different functions that collectively aim to make sure the data in corporate systems is accurate, available, and accessible. Most of the required work is done by IT and data management teams, but business users also can and should participate in some parts of the process to ensure that data meets their needs and to get them on board with policies governing its use. Here, we'll go over the basics of data management and what businesses need to know. For a deeper dive, explore our complete collection on all things data management by clicking the link above or in the description below. Data is increasingly seen as a corporate asset that can be used to make better informed business decisions, improve marketing campaigns, optimize business operations, and reduce costs, all with the goal of increasing revenue and profits. But a lack of proper data management can saddle organizations with incompatible data silos, inconsistent data sets, and data quality problems. Data management has also grown in importance as businesses are subjected to an increasing number of regulatory compliance requirements, including data privacy and protection laws such as GDPR and the California Consumer Privacy Act. Companies are also capturing ever larger volumes of data and a wider variety of data types, including a combination of structured, unstructured, and semi-structured data, all hallmarks of the big data systems many have deployed. Without good data management, such environments can become unwieldy and hard to navigate. These are the separate disciplines that are part of the overall data management process. Data architecture design provides a blueprint for managing data and deploying databases and other data platforms, including specific technologies to fit individual applications. Database administration involves various tasks for creating and managing databases, which are the most common platform used to hold corporate data. Data modeling diagrams the relationships between data elements and how data flows through systems. Data integration combines data from different data sources for operational and analytical uses. Data governance sets policies and procedures to ensure data is consistent throughout an organization. Data quality management aims to fix data errors and inconsistencies. And master data management creates a common set of reference data on things like customers and products. A wide range of technologies, tools, and techniques can be used as part of the data management process, including database management systems. A database management system, or DBMS, is software that acts as an interface between databases and the administrators, end users, and applications that access them. The most prevalent type of DBMS is the relational database management system, but other DBMS technologies are also available, in particular, NoSQL databases. Data warehouses and data lakes. They're the two most widely used repositories for managing analytics data. Data warehouses are the more traditional technology. They're based on databases and typically store structured data. Data lakes store mixed sets of big data. They're built on technologies such as the Hadoop Distributed Processing Framework, the Spark Processing Engine, and cloud object storage. A third option has also emerged, the data lake house, which combines elements of data lakes and data warehouses. Data integration methods. The most widely used integration technique is extract, transform, and load, or ETL, which pulls data from source systems, converts it into a consistent format, and loads it into a target system. Another approach that's often used in data lakes is extract, load, and transform, or ELT. It's a variation on ETL that initially leaves data in its original form. Other integration methods include real-time data integration and data virtualization. And data quality techniques. These include tasks such as data profiling, data cleansing, and data validation. Data management involves a wide range of tasks, duties, and skills. In smaller businesses with limited resources, individual workers may handle multiple roles. But in larger companies, data management teams commonly include database administrators, or DBAs, plus data architects, data modelers, database developers, data administrators, data quality analysts and engineers, and ETL developers. Data scientists, other data analysts, and data engineers who help build data pipelines and prepare data for analysis might also be part of a data management team or handle some data management tasks as part of their job duties. Data governance managers and data stewards qualify as data management professionals too, but they're usually part of a separate data governance team. At the beginning of the computer age, data management was largely driven by IT professionals who focused on solving the problem of garbage in, garbage out. Mainframe-based hierarchical databases became available in the 1960s, bringing more formality to the process. The relational database emerged in the 1970s and cemented its place at the center of the data management ecosystem during the 1980s. The idea of the data warehouse was conceived late in that decade, and early adopters began deploying data warehouses in the mid-1990s. The first release of Hadoop was available in 2006, followed by various other big data technologies, including a range of NoSQL databases. While relational platforms are still the most widely used data store by far, the rise of other alternatives has given companies a broader set of data management choices. As a result, data environments have become more complex. That's spurring the development of new technologies and processes to help make them easier to manage. They include data observability, which monitors data pipelines and data sets and identifies issues, as well as data fabric, an architectural framework for automating data integration, and data mesh, a decentralized data management architecture. In addition, cloud data management technologies are becoming pervasive, and augmented data management capabilities are helping to streamline processes. A well-executed data management strategy can benefit organizations in various ways. It can help companies gain potential competitive advantages over their business rivals by improving operational effectiveness and enabling better decision-making. Organizations with well-managed data can be more agile, making it possible to spot market trends and move to take advantage of new business opportunities more quickly. Effective data management can also help companies avoid data breaches, data collection missteps, and other data security and privacy issues that could damage their reputation at unexpected costs and put them in legal jeopardy. And ultimately, a solid approach to data management can provide better business performance by helping improve business strategies and processes. Ever-increasing data volumes complicate the data management process, especially when a mix of structured, semi-structured, and unstructured data is involved. And if an organization doesn't have a well-designed data architecture, it can end up with siloed systems that are difficult to integrate and manage in a coordinated way. That makes it harder to ensure that data sets are accurate and consistent. Even in better planned environments, enabling data scientists and other analysts to find and access relevant data can be a challenge. To help make data more accessible, many data management teams have created data catalogs that document what's available in systems. The accelerating shift to the cloud can ease some aspects of data management, but it also creates new challenges. Migrating to cloud databases, for example, can be complicated for companies that need to move data and processing workloads from existing on-premises systems. Costs are another big issue in the cloud. The use of cloud systems and managed services must be monitored closely to make sure data processing bills don't exceed budgeted amounts. Also, many data management teams are now among the employees who are accountable for protecting corporate data security and limiting potential legal liabilities for data breaches or misuse of data. There are several ways to avoid pitfalls and keep your data management process on the right track. Make data governance and data quality top priorities. A sound data governance program is a critical component of effective data management strategies. A strong focus on data quality is also a must. Be smart when deploying data management platforms. The multitude of databases and other data platforms requires a careful approach when designing an architecture and evaluating and selecting technologies. And be sure to meet business and user needs now and in the future. Data environments aren't static. New data sources are added, existing data sets change, and business needs for data evolve. To keep up, data management must be able to adapt to changing requirements. Amid the proliferation of new and disruptive technologies that can at times set businesses on their heels, and the growing reliance on data to drive business decisions and operations, well-devised data management can bring a sense of order, and may well be regarded as IT's unsung hero.